3.1 Transforming Graphs of Functions, and this lesson is focusing on translations. So we already know how to graph. That's something that's covered in previous math courses. So we can graph parabolas, lines, all sorts of things. And then what we're going to be doing differently for this unit is how to transform them and how that equation can transform them, and it'll give us strategies so that we don't have to make a table of values every time we want to graph. So we're going to do graph the function y equals x squared plus k, where k is each of these numbers. So let's start off with x squared. So let's think about the graph y equals x squared. If I plug a 1 into this, my y is going to come out as a 1. If I plug a 2 in, it's going to come up as a 4. If I plug a 3 in, it's going to come out as a 9. I like to think of functions like a box or a machine that does something. You put something into it, and it comes out as something else. Right? So the squaring is what's happening. So we're going to use that same kind of logic to graph all of these graphs. So we're going to start with y equals x squared. So it has a point at the origin. It goes one space over from the vertex and goes up 1. It goes 2 spaces over and it goes up 4. It goes 3 spaces over and it goes up 9. So there is the parabola y equals x squared. The domain of this function is all the real numbers. The range of this function is greater than or equal to 0 for all the real numbers. Okay, so that's nothing new. If we were to graph the function y equals x squared plus 3, so this one is x squared plus 0. What this means is I'm going to square this number, and then I'm going to add 3 to it. So 1 squared is 1, plus 3 more is 4. So really what you're doing is you're taking each of these things and you're increasing it by 3, which means that it's going to start here at 1. So what this is actually doing is it's called a vertical translation. We've moved it up for 3 spaces. So now this graph looks exactly the same. It just starts at this new location. So I'd go over 1, up 1, over 2, up 4 on both sides, over 3, up 9. We're not going to have room for that. So the shape doesn't change. It just is literally like picking it up and moving it somewhere else. So for our domain, it would be all the real numbers. That doesn't change. And our range is greater than or equal to 3 because we have a new vertex. Okay, last one. We're going to use a negative 3. So it's having a vertical translation 3 down. So instead of starting at 0, it's going to start here at negative 3. Then we're going to use the same table of values. So over 1, up 1. Over 2, up 4. I went too many spaces there. Over 3, up 9. So this graph would look like that. So again, same shape, it has just been moved. The domain for this function is all the real numbers. The range is greater than or equal to negative 3. Alright, so that's a vertical translation. Now we're going to do a horizontal translation. Oh, by the way, we're using this letter K right there for vertical. Okay, now we have H. So it's inside the brackets. That's where our difference is. So we're going to have 0, 4, and negative 3. So just like last graph, or last function, we're going to do a normal x squared function. 1, 1, 2, 4, 3, 9. And we'll start with that. Oops. So there is our function. And we already know the domain is all the real numbers, and the range is greater than or equal to 0 for the real numbers. Okay, now we're going to horizontally translate it. Now when you are doing this, because there is a negative sign in here, it's always going to be the opposite sign. So if I wanted to do the equation where h is 4, it would be x minus 4. See how it looks like it's a negative now? But really what that 4 is it means I'm going 4 to the right. So I'm going to start my parabola here. And then I'm going to do the exact same thing. 1 over up 1, over 2 up 4, over 3 up 9. So it doesn't actually change the shape of the graph. It just changes where the graph starts. There you go. So our domain doesn't change, and our range also doesn't change. It's the same thing. All right, now we're going to do a negative 3. So if I was to plug this into the equation, it would be minus a negative 3. So it turns into be plus 3. So we're going to go 3 to the left this time. So negative means to the left, positive means to the right, and we flip the signs, bringing it out of the brackets. Okay, so starting at 3, we're going to go over 1, up 1, over 2, up 4, over 3, up 9. And there's my graph. And again, the domain doesn't change. It's all the real numbers. And same with the range. Okay, so that's our two types of translations. Okay, so we're going to translate, transform these graphs. So first off, there's a definition up there. It's called a lattice point. What a lattice point means is it's a point that intersects exactly on in between two grid lines. Like these are all lattice points. They're easy to translate. Oops. Okay, so here's the graph of y equals g of x. Sketch the image graph after each translation. Write the equation of the image graph in terms of the function. So we want to go 4 units to the left. So we're going to do it with a table of values. You don't always have to do a table of values, but it will get useful as it gets more difficult. So we have x and y as our points, and it's going to go 4 to the left. So I'm going to take my x values and subtract 4. So let's figure out what all these points are. We have 1 at -1 and 3. We have a point at 2 and 4. We have a point at 4 and 2. And our last point is at 6 and 5. So without even graphing it, we can figure out the new points here. Oh, let's go back and do the domain and range for this before we start. So the domain for this function is the smallest x value is -1. So we have -1 is less than or equal to x, less than or equal to 6 for real numbers. And our range, our lowest point is right here, and our highest point is right here. So what is that? 2 less than or equal to y, less than or equal to 5? Yeah, 5. Okay. I always forget to do domain and range. And you have to do it pretty much on every question, so we'll make sure we do that. Okay, so we're just going to take all of our x points and subtract 4 from them. So this is going to change into -5 and 3. This is going to change into -2 and 4. This is going to change into 0 and 2. And the last one will be 2 and 5. just know that it's not changing our y values at all. So we can go ahead and plot those points. If plotting the points is so much work and you just want to count 4 to the left for each of them, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then you are done. That's obviously easier, but it will get more complicated. Okay, domain for this one is, it's going to change because now we're 4 to the left, so we're going to minus 4 from this number and minus 4 from this number. So negative 5 less than or equal to x less than or equal to 2. I ran out of room. And the range doesn't change because we didn't do anything to the y. Okay, now let's do the next one, 1 unit up. So we already know our x and our y's from the last question. Negative 1, 3, 2, 4, 4, 2, and 6 and 5. This question, the x isn't going to change, the y is going to increase by 1. So it's going to, the x's are all going to stay the same, the y's are all going to get 1 bigger. There we go. And again, to plot it, we can just count. I mean, it's pretty straightforward. You're just going to plot it one above. And there's our graph. So the domain doesn't change because we didn't do anything to the y. The range, each of those numbers from here are going to increase by 1. So 3 less than or equal to y less than or equal to 6. Okay, so we're going to use this to sketch. So this function is going to, we already did that, never mind. It said write the equation, but we already did that. Okay, so we're going to go 4 units left and 5 units down. Okay, so we have x and y, and then our x is going to be 4 units to the left, so x minus 4, and y is going to be 5 units down, so y minus 5. We want to write an equation for this, so we're going to start with this. Y minus k equals fx minus h, and we're going to plug in our translations here. So we have y, and we're going down 5, so minus 5. And we're going left 4. So we'd have y plus 5 equals f x plus 4. So this is our explicit equation. Just plugging in those translations. Okay, so we need some lattice points to help us graph this. So we have these points right here. We can go with these vertexes. Yeah, we might want some on the outsides here, and probably this vertex. So the points that I chose were negative 1, 0.8, and 6. It's supposed to be a decimal. Oh my gosh. Negative 1 and 0, 0 and 4, 1 and, or 0.5, and like 5.1, 1 and 4, 2 and 0, and 2.8 and 6. Okay, so we're going to subtract 4 from our x's and subtract 5 from our y's. So I want you to pause the video and I want you to fill in this side of the chart. So you should get negative 5.8 and 1. And you should get negative 5 and negative 5, negative 4 and negative 1, negative 3.5 and 0.1, negative 3, negative 1, negative 2, negative 5, and negative 1.2 and 1. So we're going to go graph all of these points, and you can follow along, or you can use the counting method where you just count 4 left, 5 down. So 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. And then it's like right above it. And you should be able to actually just graph it now because it's all pretty equal. Okay, so it will look like this. And you've transformed it. Okay, man, I forgot to do the domain and range. Let's do the domain and range on the first function. So it is all the real numbers. And the range just has to be greater than these vertexes or these local minimums. So greater than 0. And we'll do the domain and range on the new function. Again, the domain doesn't change. It's still all the real numbers. And the range is greater than or equal to -5. And there we go. Okay, the graph of y equals 1 over x is translated 3 units left and 2 units up. What is an equation for the image graph? So we are going to go y minus k equals 1 over x minus h. And we're going to just plug those numbers in. So 3 units left is going to affect my h. So x minus -3. And 2 units up is going to affect my k, so 2. So we have y minus 2 equals 1 over x plus 3, and there is my equation. What are the equations of the asymptotes of each of these images when there's been translations, obviously? So the first one, we have y minus 3 equals 1 over x squared. This graph right here is y equals 1 over x squared. The domain and range for this function, the domain is x cannot equal 0, and the range is y has to be greater than or equal to 0. Okay, so now let's transform it. We have a k value of 3, positive 3, so we are doing a vertical translation. And we're going to be going 3 up. So that's not going to change my horizontal asymptote, but it is going to change, it is going to change my horizontal asymptote. It is not going to change my vertical asymptote. So this graph is just going to look like that. And it just starts 3 higher. Okay, the domain and range for this one, domain is the same, it still can't equal 0. And the range is 3 up. So greater than or equal, or greater than, not equal to, 3. Same with that one. I erased it over here. Okay. Next one. We have 2 translations. We have a translation of 4 to the down, a vertical translation. And we have a horizontal translation from this, 1 to the left. One left. Okay, so our asymptotes this one is going to be moved 4 down, and our vertical one is going to be moved 1 to the left. And now we can just sketch using the asymptotes. Right, there you go. And that is how we do translations. Thank you for subscribing below, and I'll see you in my next videos. Bye!